This is Edexcel Further Pure 1, Trigonometry, the T formula, using the T formula. And here are the three T formulae: sine theta, cos theta, and tan theta, all in terms of T, where T is the tangent of the half angle. We've also seen that there's a couple of triangles that we can end up using to help us remember those. You still need to make sure you learn these, and they can be quoted unless a question asks for them to be derived. So we'll go ahead and use those T formulae. In this example, we're given the value of T, tan theta over 2, and we're told it's 2/5. In the first part of the question, we're asked for the cosine of theta over 2. So to help me remember that, I'll draw a triangle with an acute angle of theta over 2. I know that has a tangent of t, so I've set up my side suitably to get a tangent of t, and by Pythag I can get the square root of 1 plus t squared as the hypotenuse. Cosine is going to be the adjacent, which is 1, over the hypotenuse, which is the square root of 1 plus t squared. I'm told that t is 2/5, so that's going to be equal to 1 over the square root of 1 plus, and 2/5 squared, 4/25. And if I multiply both numerator and denominator by 5, I can then move that inside my third sign and it becomes 25, so I end up with 25 plus 4, root 29. In the second and third part, we're asked for trig functions of theta. So I'm going to need a different triangle this time to help me work out what they should be. And I've got an acute angle of theta. And the hypotenuse is going to be 1 plus t squared. The opposite is 2t. And the adjacent is 1 minus t squared. So now I've set up that triangle, I can end up working out what sine theta is going to be. So sine theta is going to be 2t over 1 plus t squared. And inserting the value of 2/5 for t, I'll end up getting 2 times 2/5, 4/5, over 1 plus, and we already worked out t squared, 4/25. I'll multiply top and bottom by 25 to get rid of fractions on the denominator, and that'll give me 20 for the numerator and 29 for the denominator. And there's that done. The last one is sec theta, so that's going to be 1 over cos theta. Now for cos theta, it would normally be 1 minus t squared over 1 plus t squared, but because I'm taking the reciprocal, I've got to take the reciprocal of the cos as well. So that's going to be 1 plus t squared over 1 minus t squared. So that's 1 plus 4/25 over 1 minus 4/25. And then if we multiply both top and bottom by 25, we end up with 29 over 21. And here are those workings written out slightly more neatly, so you can freeze the video if you need to follow those through in more detail. In this example, we're not given the value for t, but we're told to use the t formula. So we're going to need to see if we can work that out. We're given the sine of theta over 2, and we're also told that theta over 2 is between pi over 2 and pi. Now I can find cosine of theta over 2 by using sine squared plus cos squared equals 1. And if we examine this particular fraction here, 5 and 13ths, that's going to be part of a 5, 12, 13 triangle. So we can say that the absolute value of cos theta over 2 is going to be 12/13. But we then need to use the information in the second part of the question that tells us that the cosine is going to be negative. So we know that the cosine is going to be negative 12/13. With both cos theta over 2 and sine theta over 2, we can then work out tan theta over 2, which is our t. That's what we need to do to be able to use the t formula. And tan theta over 2 will be sine theta over 2 divided by cos theta over 2. The 13ths will end up cancelling out, so we will end up with 5 over negative 12. And of course, we just tidy that up to be 5 over 12, negative 5 over 12. Right, so now we can start working on the meat of the question. So cos theta is going to be equal to 1 minus t squared over 1 plus t squared. We can now substitute in the value of minus 5/12 into these terms. So 1 minus, well, as I'm squaring a negative number, it still becomes positive, so it still ends up being a takeaway here at 25 over 144 over 1 plus 25 over 144. And then if we multiply top and bottom by 144, and on the top we're taking away 25, which will give us 119. And on the denominator we're adding 25, so that will give us 169. Cot theta is a reciprocal trig function. That's 1 over tan theta. Tan theta would be 2t over 1 minus t squared. But we need to take the reciprocal of that, so that's going to be 1 minus t squared over 2t. We pop in the value, and the negative is going to be important this time. 1 minus 25 over 144 over minus 10 over 12. Again, multiplying numerator and denominator by 144, we end up getting the same numerator as we had before, 119. And I end up multiplying the bottom by 144, so it's 10 times 12, and it's a negative, so it's 120. And of course, just to finish it off, we'll take the negative up to the numerator. And here it is written out somewhat more neatly. In this two-part question, we're given the cosine of an angle and the range within which that angle fits, and we're asked to find sine theta. Well, that's going to be cos squared plus sine squared equals 1, taking into account the range within which the angle falls. That's really just GCSE maths. So we'll move straight on to the second part, and it's saying use the t formula to find tan 2 theta. So we've doubled the angle that we're interested in, so we need to double the value of the angle in the t formula. So instead of t being tan theta over 2, in this case we're looking for t to be tan theta. And tan theta is sine theta over cos theta. Now we've got the same denominator on both sine theta and cos theta, so those are going to cancel out, so I can just use the numerators to give me my tan theta. So that's 1 plus root 3 over 1 minus root 3. So tan 2 theta is going to be equal to 2t over 1 minus t squared. And 2t, if I take quite a complicated fraction here, 2 plus 2 root 3 over 1 minus root 3 all over 1 minus, all in brackets, 1 plus root 3 over 1 minus root 3 all squared. And if you put that into a calculator, you end up getting 1 over root 3. And this is one of the trigonometric values you should know. So that means that 2 theta is going to be pi over 6 and 7 pi over 6, and keep on adding pi for all the ones beyond that. So that gives us all those solutions. Now we're told that theta itself lies in the range pi over 2 to pi. Well, pi over 12 isn't in that range, but 7 pi over 12 is. So our only solution is 7 pi over 12. The next one, 13 pi over 6, leads to 13 pi over 12, and that's bigger than pi. So this is our only solution. And here are the workings for the first part of the question. And the key point here is that we're taking the positive square root because of the range within which theta falls. We know that between pi over 2 and pi, sine theta will be positive. And here is the working for the second part of the question. And instead of just putting the workings into a calculator, I've actually done it longhand so that you can see all of the workings out there without a calculator. So here are the 3 formulae that we need. And to help commit them to memory, we have these visual representations using 2 triangles. And that's all associated with t being tan theta over 2. Of course, you can double up those angles as we saw in the last question. Strong familiarity with these formulae is required to succeed. That was Edexcel Further Pure 1, Trigonometry, the T formula, using the T formula. Next up, application of T formula to trigonometric identities.